Good day, everyone. We are Group 4 and we will be presenting Chapter 5 from the field of Management Science. Our focus for today's video centers around the subject of decision theory. We have 7 reporters today. Starting with me, I am Catherine J. Licudo. I will enlighten you about the meaning of decision theory and about the types of decision-making environment. Following me, Ms. Jessamay Corpus will continue to discuss the remaining criteria in making decisions, such as criterion realism and minimax, as well as the remaining types of decision-making environment, which is decision-making under risk. Next up, we have Ms. Amriza Joy Casagan, our third reporter. She will explain to you the expected monetary value approach without perfect information. Miss Ivy Marayag, our fourth reporter, as she will explain to you the expected opportunity loss approach. Then, Miss Angeline Bareng, she will demonstrate the decision tree and marginal analysis with large number of alternative and its states of nature. Miss Rachel Ashley Pagatwan will be our second to the last reporter. She will discuss the discrete distribution and a quantitative approach to decision making. Finally, Ms. Rain Alpa Tolentino will wrap up our presentation by discussing marginal analysis with normal distribution. We are committed to ensuring that this presentation is engaging and informative, so please feel free to ask questions and seek clarification on Monday. We hope that this presentation will not only inform you but also inspire thoughtful discussions and solutions related to decision theory. Without further ado, let's begin this presentation, and may it both enlightening and enjoyable for all of us. So sit back, relax, and learn. So what is decision theory? The decision theory is an analytic approach to make an economic decision by systematically defining and analyzing a problem using a mathematical model. This process involves listing possible alternatives and possible outcomes. The given values in problem are presented in a decision table or payoff table. To make it clear, ang decision theory daw ay isang analytical approach kung saan tinutulungan nito yung mga individuals, organization, or decision makers sa paggawa o pagpili ng informed choices sa pamamagitan ng evaluating various factors and using mathematical models to analyze and solve decision-making problems. There are 6 steps involved in decision making. The first steps in decision making is to clearly define the problem or the decision to be made. Dito, it involves identifying the objectives, constraint, and or any factor or variables that are relevant to that decision. For example, imagine a farmer trying to decide whether to plant wheat or corn next season, depending on the weather forecast. The farmer's objective is to maximize profit. Thus, the problem is, which is more profitable to plant? Is it wheat or corn? Always remember, a well-defined problem set the stage for the entire decision-making process. Siyempre, if hindi, the process can be aimless and yung decision na gagawin mo is maaaring hindi magandang kakalabasan nito. Therefore, to make effective decision, it is essential to invest time and effort in precisely defining the problem you're trying to solve. The second step is to list the alternatives. Siyempre, pagkatapos mo ma-define yung problem, you need to identify and list all the possible alternatives or choices available to you. And these alternatives represent the different courses of action that can be taken para ma-address yung problem and ma-achieve mo yung objectives. Uh, it is important to consider a comprehensive set of options para syempre matitignan mo kung saan may mas malaking chance of success. Dito sa example natin, the farmer can choose between two alternatives. Yung number one is to plant wheat and number two is to plant corn. The third step is to identify the possible outcome. So, dito, para sa bawat alternative, kailangan i-consider mo yung mga possible outcomes or results that may occur if that alternative is chosen. This outcome may be favorable or unfavorable and can be vary in terms of magnitude, probability, or impact. So, sa example natin, if the farmer plant wheat or corn and the weather is good, the possible outcome could be high profit. And if the weather is bad, expected na yung possible outcome is low profit. The fourth step is to list the payoffs or conditional values. Sa example natin, if the farmers plants wheat and the weather is good, the profit is 10,000 pesos. Kapag yung weather naman is bad, the profit is 2,000 pesos. However, if the farmer plants corn and the weather is good, the profit is 8,000 pesos. Kapag yung weather naman is bad, the profit is 5,000 pesos. Additionally, the weather forecast predicts a 70% chance of good weather and a 30% chance of bad weather. Dito, yung payoffs or conditional values represent the quantitative or qualitative measures associated with each combination of alternative and outcome. This can be expressed in terms of monetary values, utility, satisfaction, or any relevant units. The payoffs ay nakakatulong in evaluating and comparing the desirability or of different choices under the different circumstances. The decision theory uses the concept of expected monetary value. The expected monetary value is dependent on two important elements, namely, the probability and the amount of money involved. So, para makuha yung expected monetary value, yung probability ay imumultiply sa amount of money. So, kung titignan nyo yung solution, yung planting wheat ay may expected profit na 7,600 pesos, while planting corn ay may expected profit na 7,100 pesos. So, yung last step is to make a decision. A decision can be made based on the analysis conducted using the mathematical model and the information gathered. So, dito, after the calculation and nakuha na yung expected profit, dito magbe-base yung farmer ng kanyang decision. And the farmer would choose to plant wheat kasi syempre, pipiliin niya yung may higher expected profit amounting to 7,600 pesos. So let's proceed to the decision-making environment. Decision makers heavily consider the information existing in a particular environment. The following are the types of decision environment that surround a decision maker. Number 1, decision making under certainty. Number 2, decision making under uncertainty. And number 3, decision making under risk. So dito, ang decision-making environment ay tumutukoy sa set of conditions, factors, and circumstances kung saan yung mga individuals or organization make choices and decision. Ang nature ng decision-making environment ay maaaring makakaapekto sa decision-making process and outcome ng mga decision na iyon. So, para mas maliwanagan kayo, i-discuss natin isa-isa itong tatlong types of decision environment. The first type is the decision-making under certainty. Sabi dito, it does not pose any problem to a decision maker because he or she knows with certainty the outcomes of his or her decision. He or she select the alternative that gives a high payoff or maximize the profit. So, yung decision making under certainty, tumutukoy sa isang sitwasyon kung saan you have all the information that you need para makagawa ng decision. And there's no doubt about sa magiging outcome of your choices. So, sa madaling salita, sigurado ka kung kung ano yung mangyayari based on your decision. Kumbaga, sa real life situation, for example, sabi mo magre-review ka ng 2 a.m. Kaya, nag-set ka ng alarm. And yung alarm clock mo is gumagana talaga and malakas yung ringtone. So, doon pa lang, you can be certain that it will wake you up at 2 a.m. Therefore, decision making under certainty is the simplest type of decision making because you know exactly what will happen based on your choices and there is no risk or unknown involved. The second type of the decision-making environment is the decision-making under uncertainty. Ano nga ba yung decision-making under uncertainty? Ito ay kabaliktaran ng decision-making under certainty. Yung decision-making under certainty, sigurado ka sa mangyayari. And dito naman, sa decision-making under uncertainty, hindi mo alam kung ano yung mangyayari. So, sabi dito, decision-making under certainty happens when the probability of the concurrence of any outcome is not available and or is unknown to the decision maker. The decision is highly dependent on a particular criterion or the orientation of the decision maker. Dito kasi sa decision making under uncertainties like making choices when you don't have all the information you need and hindi ka sure sa magiging outcomes. Ito ay medyo katulad sa pag-take ng chances o sugal dahil hindi mo alam kung ano yung mangyayari. For example, para mas maliwanagan kayo, kunyari, you are starting a new business. You want to start a new business and dito, hindi ka certain if it will be successful ba. Kaya, nag-research ka, nag-plan, and make your best guess. But, yung future is uncertain and you can predict it with absolute confidence. Walang kasigaruduhan na magiging successful yung business mo since um, pwedeng, madaming pwedeng mangyayari na hindi maasahan. Therefore, in this situation, you have to weigh the potential risk and reward, use the information available, and make the best decision you can with the uncertainty in mind. And there are different criteria in making decisions under uncertainty. The first one is maximax. Number 2, maximin. Number 3, equal likely. Number 4, criterion of realism. And number 5 is minimax. So, para mas maintindihan natin itong limang criteria, may illustration dito. Illustration 1. As it expands its operation, Miss Salvin Bank is confronted with the problem of whether to establish a full-blown branch or a branch-like unit in the municipality it desired to expand in or not at all. The payoff table of Miss Salvin Bank is as follows. Dito makikita na the decision table has three alternatives. The first one is establish a full-blown branch. Second, establish a branch-like unit. And the third is not establish a full-blown branch or nor a branch-like unit. There are two states of nature, namely favorable and unfavorable market condition. In the decision theory, the state of nature refers to the outcome that the decision maker has little or no control over. So, yung first criteria is the maximax. In the maximax criterion, the decision maker adopts an optimistic approach. He or she selects the alternative that has the highest possible gain or maximizes the outcome for every alternative. Once the highest possible gain of all alternative has been determined, the alternative with highest maximum value is chosen. Kung titignan yung payoff table ni Miss Salvin Bank, the first alternative has maximum outcome of 300,000 pesos gain, and the second has 150,000 gain, and the third has 0. Dito, yung pipiliin niya is yung alternative na may highest possible gain, which is the establish of full-blown branch na may 300,000 pesos na value. The second criteria is the maximum. In the maximum criterion, the decision maker maximizes the minimum outcome for every alternative and select the alternative that has the least possible loss. The decision maker in this case adopts the pessimistic approach. So dito, yung decision maker nagiging pessimistic. Ano nga ba yung pessimistic? Ito yung ugali ng isang tao kung saan mahilig nilang tignan yung worst outcome ng isang bagay. Doon sila nagfo-focus, which is okay naman kasi makakatulong para mas malaman o makita nila kung ano yung negative outcome sa mga alternative na pagpipilian nila. Kung titignan natin yung payoff table ni Miss Salvin Bank, alternative 1 has the minimum outcome of 200,000 loss, and the alternative 2 has 40,000 loss, and the alternative 3 has 0. The alternative that has the least possible loss is the alternative 3, which is 0. So, always remember na kapag yung maximum, ang decision maker ay pinipili niya yung alternative na may pinakamababang possible loss. The third criteria is the equally likely. The equally likely criterion, otherwise known as the Laplace criterion, selects the alternative that has the highest average value. The decision maker adopts an approach in which the states of nature have equal changes. In this criterion, the average value of every alternative computed. Dito, kukunin mo yung sum of all outcomes, yung gain and loss in the alternative, divided by the number of outcomes. And the highest average value is selected. As we can see, the alternative with highest average value is the established a branch-like unit, may average value na 55,000 pesos.
Criterion of realism. The criterion of realism, otherwise known as the Hurwitz criterion, adopts the weighted average approach wherein the coefficient of realism, A, is used. It is an approach that it is a compromise between the maximax and maximum criteria. The coefficient of realism has a value ranging between 0 and 1. A coefficient close to 1 indicates optimism about the future, while a coefficient value close to 0 indicates pessimism. So, Hurwitz's criterion is a decision-making approach that helps you choose the best decision under uncertainty. Here's how it works. So, imagine you have to make a decision but you're not sure about the future outcomes. Hurwitz's criterion helps you balance optimism and pessimism when making choices. It involves two factors. Number one is optimism, which is the A, and this represents how optimistic or hopeful you are about the best possible outcome. If you're feeling very optimistic, you might lean more towards the best case scenario. Number two is pessimism. It is the 1 less A. This represents how pessimistic or cautious you are about the worst possible outcome. If you're feeling very pessimistic, you might focus more on avoiding the worst case scenario. Hurwitz's criterion combines these factors to calculate the expected payoff for each decision and helps you choose the decision with the highest expected value, considering both the best and worst case scenarios. In simple terms, Hurwitz's criterion helps you make decisions by finding a balance between optimism and pessimism, allowing you to consider a range of possible outcomes and make a choice that best fits your attitude toward risk and uncertainty. So, in the example, in the given problem, the formula to compute the amount of the criterion of realism is as follows. So, criterion of realism. A is the maximum value in the alternative, and the 1 less A is the minimum value in the alternative. So, assume that Miss Salvin Bank sets the coefficient of realism equal to 0.80. The criterion of realism is determined as follows. So, first alternative is establish a full-blown branch. 0.80 times 300,000 plus 0.20 times negative 200,000 is equal to the average value in peso is 200,000. And then the next alternative is establish a branch-like unit. So 0.80 times 150,000 plus 0.20 times negative 40,000 is equal to 112 average value in peso. And lastly, not establish a full-blown branch nor a branch-like unit. The computation both in average value in pesos and the average value is 0. So, the alternative with the highest criterion of realism is the establish a full-blown branch, which is the computed average value in peso is 200,000. So, the next criteria in decision making under uncertainty is minimax. So, here in minimax, imagine you're playing a game like chess or tic-tac-toe, where you have to make moves without knowing your opponent moves in advance. The minimax strategy is like thinking ahead and trying to predict what your opponent might do. So, here's how it works. The word mean is means minimize your loss. When you make a move, you consider the worst case scenario, where your opponent makes the best possible move against you. You minimize your potential loss by choosing a move that gives you the best chance of survival even in the worst situation. So, the word max means maximize your gain. On the flip side, where opponent make a move, you think about the best move you can make in response. You aim to maximize your potential gain by choosing a move that puts you in the most advantageous position, assuming your opponent will play optimally. So, minimax is all about being cautious and strategic. You think ahead, anticipating the best moves your opponent might make, and you counteract those moves by minimizing your losses and maximizing your gains. It's a smart way to approach games where you don't know your opponent will do next. So, let's move on in the problem. In the minimax criterion, the payoff table is converted into an opportunity loss table. Then, the alternative with the minimum opportunity loss is selected. The following steps are observed in converting a payoff table to an opportunity loss table. So, the first step is find the maximum payoff per column. Second is determine the opportunity loss by column. And third is select the alternative with the minimum opportunity loss. So, using the payoff table of Miss Salvin Bank, the following steps are performed to select the alternative under the minimax criterion. So, step 1, find the maximum payoff per column. So, the maximum payoff in column 1 with the values 300,000, 150,000, and 0 is 300,000. In column 2, the values are negative 200,000 and negative 40,000 and 0. Hence, the maximum payoff is 0. So, step 2, determine the opportunity loss by column. The opportunity loss by column is computed as follows. So, alternative 1 is establish a full-blown branch. 300k less 300,000 is equal to 0. And 0 less 200,000 is equal to 200,000. So the next is establish a branch-like unit. 300,000 less 50,000 is equal to 250,000 and 0 less negative 40,000 is equal to 40,000. So last is not establish a full-blown branch nor a branch-like unit. So in the market condition in peso is 300,000 less 0 is equal to 300,000, and of course in market condition in peso is 0 less 0 is equal to 0. So, the last type of decision environment that surrounds a decision maker is the decision making under risk. So, let me explain this first. Decision making under risk means making choices when you know possible outcomes, but not how likely they are. You figure out the chances of different outcomes happening and their values, like profits. Then you pick the choice with the best average result. It's like making smart decisions in a game where you don't know what all the rules, but you have some hints about what might happen. In this context, decision makers use probability distributions and statistical analysis to assess the likelihood of different outcomes. Decision making under risk make use of probability. The two methods primarily used when making a decision under risk are the expected monetary value approach and the expected opportunity loss approach, which will be tackled by my other groupmates. So let me explain first what probability is. So probability is a statistical measure of certainty that an event will happen. Its values ranges from 0 to 1. If the probability is equal to 0, the event will never happen. However, if the probability is equal to 1, there is a 100% probability that an event will occur. The probability that an event will happen plus the probability that an event will not happen is always equal to 1. Probability is discussed in length in the field of statistics and it is not within the scope of this book.
So, expected monetary value. There are two variations of expected monetary value. The expected monetary value approach without perfect information and expected monetary value approach with perfect information. Dun muna tayo sa expected monetary value approach without perfect information is computed as follows. Expected monetary value, alternative first state of nature payoff times probability of the first state of nature. Second state of nature payoff times probability of the second state of nature plus the last state of nature payoff times amount of money. So, may illustration to dito. Expected monetary value approach without perfect information. The payoff table of Miss Salvin Bank is presented as follows. So, may table dito. Alternatives, favorable market condition in peso, unfavorable market condition in peso. Establish a full-blown branch is favorable market condition is 300,000 and unfavorable is negative 200,000. Then establish a branch light unit. The favorable market condition is 150,000 and unfavorable is negative 40,000. And then not establish a full-blown branch nor a branch light unit. Favorable is 0 and unfavorable is 0 then assume the following probabilities. Case 1 is favorable market condition is 60% and then the unfavorable market condition is 40%. Sa case 2 naman is favorable market condition niya is 50%, then unfavorable market condition is 50% then. Expected monetary value approach without perfect information is computed as follows. Ito yung sagot sa table kanina. Case 1, the expected monetary value of each alternative is determined as follows. Expected monetary value full-blown branch is equal to 300,000 times 60% plus negative 200,000 times 40% is equal to 100,000 peso. Expected monetary value branch light unit equals to favorable market condition na 150,000 times 60% plus unfavorable market condition na negative 40,000 times 40% is equal to 74,000 pesos. The expected monetary value naman is no full-blown branch nor branch-light unit equals to favorable market condition na 0 times 60% plus unfavorable market condition na 0 times 40% is equal to 0. So, sa case 2 naman tayo. The expected monetary value of each alternative is determined as follows. Expected monetary value, full-blown branch, is equal to favorable market condition na 300,000 times 50% plus unfavorable market condition na negative 200,000 pesos times 50% is equal to 50,000 pesos. Ito lang tayo sa expected monetary value branch light unit equals to ganun din. Favorable na 150,000 times 50% plus unfavorable na negative 40,000 times 50% is equal to 55,000 pesos. Then the last one is expected monetary value, no full-blown branch nor branch light unit. Then 0 times 50% plus 0 times 50% is 0. Then it's equals to 0. Expected monetary value with perfect information is equal to maximum payoff of state of nature 1 times probability of state of nature 1 plus maximum payoff of state of nature 2 times probability of state of nature 2 plus maximum payoff of state of nature times probability of state of nature. Formula, expected monetary value of perfect information is equal to expected monetary value with perfect information minus expected monetary value without perfect information. Expected monetary value approach with perfect information. So this is the illustration 3. The probabilities are as follows. Number 1, favorable market condition, state of nature 1 is equal to 60%. And then number 2 is unfavorable market condition, state of nature 2 is equal to 40%. So determine the following. Number 1, expected monetary value with perfect information. Then number 2 is expected monetary value of perfect information. Then the last one is the amount of gain if Princess Bank buys the perfect information for 50,000 pesos. Expected monetary value approach with perfect information. So sa answer 1 is may tatlo tayong gagawin na susunod steps. So step 1, find the maximum payoff per state of nature. Yung amount dito is kukunin natin sa illustration 2. Sa illustration 2. The maximum payoff per column is determined as follows. State of nature 1, 300,000, then 150,000 as 0 is equal to 300,000. State of nature 2 is negative 200,000, then negative 40,000 tapos yung 0 pesos, then is equal to 0. So, sa step 2, multiply the determined maximum payoff per column by the probability. The value is determined as follows. Then the state of nature 1, 300,000 times 60% is equal to 180,000. Then sa state of nature 2, 0 times 40,000 is equal to 0. Then the last one is step 3. Add all the value in step 2 to get the expected expected monetary value with perfect information. Expected monetary value with perfect information na 180,000 plus 0 is equal to 180,000 pesos. Answer 2, the expected monetary value of perfect information is computed as follows. So, expected monetary value of perfect information is equal to expected monetary value with perfect information minus expected monetary value without perfect information. So, kuha natin yung 180,000 minus 100,000 is equal to 80,000 pesos. Then the answer 3, the cost of perfect information is 50,000 pesos. The amount of gain is computed as follows. Amount of gain is equal to 80,000 pesos minus 50,000 pesos is equal to 30,000 pesos.
So now let's move on to the next topic, which is expected opportunity loss approach. First, ano nga ba tong expected opportunity loss? So expected opportunity loss is a risk measure used in decision making under uncertainty. When we say uncertainty, ito ay tumutukoy sa mga sitwasyon kung saan nahaharap ang mga negosyo sa mga panganib na hindi nahuhulaan o nasusukat. Expected opportunity loss quantifies the potential loss of making an incorrect choice given the probabilities of a different states of nature. To contrast, the EMV approach maximizes the expected monetary value, while the EOL approach minimizes the expected opportunity loss. Ang EOL is a useful tool para sa mga gumagawa ng desisyon dahil isinasaalang-alang nito ang kawalan ng katiyakan sa hinaharap at ang mga potensyal na kahihinatnan ng paggawa ng maling desisyon. Maaaring gamitin ang EOL upang ihambing ang iba't ibang mga alternatibong desisyon at piliin ang isa na may lowest expected opportunity loss. The following are the steps in the EOL approach. First is to construct an opportunity loss table. Second is to determine the expected opportunity loss of every alternative. Lastly, select the alternative with the lowest EOL value. We can see in this slide the payoff table of Miss Salvin Bank. The first column is the alternatives, second's favorable market condition in peso, and the third column is unfavorable market condition in peso. Establish a full down branch is the first alternative, which has 300,000 favorable market conditions and negative 200,000 unfavorable market conditions. Establish a branch-like unit is the second alternative, which has 150,000 favorable market conditions and negative 40,000 unfavorable market conditions. Not establish a full-blown branch nor a branch-like unit is the last alternative, which has 0 favorable market conditions and 0 unfavorable market conditions. The probabilities are 60% for favorable market conditions and 40% for unfavorable market conditions. The following steps are performed to determine which alternative should be selected. So now, we need to apply the first step, which is construct an opportunity loss table. To construct an opportunity loss table, the maximum payoff per column is determined. 300,000 for column 2 and 0 for column 3. Focus on the second column first. 300,000 less 300 is equals to 0. 300,000 less 150,000 is equals to 150,000, and 300,000 less 0 is equals to 300,000. Let's move on to the third column. 0 less negative 200,000 is equals to positive 200,000. 0 less negative 40,000 is equals to positive 40,000, and 0 less 0 is equals to 0. The opportunity loss table appears as follows. Establish a full down branch has 0 favorable market conditions and 200,000 unfavorable market conditions. Second, establish a branch-like unit has 150,000 favorable market conditions and 40,000 unfavorable market conditions. Lastly, not establish a full-blown branch nor a branch-like unit has 300,000 favorable market conditions and 0 unfavorable market conditions. Step 2. Determine the expected opportunity loss of every alternative. Multiply the probabilities of the state of nature by the opportunity loss. The computation appears as follows. As I said earlier, the probabilities are 60% for favorable market conditions and 40% for unfavorable market conditions. So 0 times 60% is equals to 0. 200,000 times 40% is equals to 80,000. So 0 plus 80,000 is equals to 80,000. 150,000 times 60% is equals to 90,000, whereas 40,000 times 40% is equals to 16,000. 90,000 plus 16,000, we come up to 106,000. 300,000 times 60% is equals to 180,000. 0 times 40% is equals to 0. So, 180 plus 0 is equals to 180,000. So now, let's move on to the last step, which is selecting the alternative with the lowest expected opportunity loss value. Since the expected opportunity loss value is lowest at 80,000, the best decision is to open a full-blown branch. Sa madaling salita, nagpasya ang kumpanya to open a full-blown branch dahil ang inaasahan nitong mawawala ang pinakamaliit na halaga kung gagawin ito. Ang halaga ng EOL na 80,000 represents the company's estimate of the average amount of money it would lose if it made the wrong decision. It can be observed that the EMV approach obtained the same result as the EOL approach, which is to establish a full down branch. The lowest amount of the EOL is the EMV of perfect information.
Let us now proceed to decision 3. First, let me define what decision is. Decision is a choice that you make about something after thinking about several choices, and it is a choice that you made with an alternative courses of action in a situation of uncertainty. Let us define decision 3. Decision 3 is a graphical approach to representing a payoff table or decision table. It contains the points, state of nature, points, and the alternatives. So, decision 3 is a map of possible outcomes of a series of related choices. It allows individuals or organizations to choose the best actions against one another based on their costs, probabilities, and their benefits. Kaya siya tinawag na decision tree kasi it starts with the single nodes which branches into possible outcomes, then those possible outcomes added additional nodes which branch off into other possibilities. Para siyang puno na magkakaroon ng sanga-sanga or magkakaroon ng mga branches. Kapag gagawa tayo ng decision tree, we should consider the 3 different nodes. The decision node, the chance node, and the alternative. So the chance nodes is represented by the circle, which it shows the probabilities of the outcomes. And the decision node represented by the rectangle, which shows a decision to be made. And then alternatives represented by the arrows, which shows the choices of the possible outcomes. So, itong decision tree, ginagamit siya to clarify and find answer into complex problems and to weigh the possible actions against one another based on their costs, probabilities, and benefits. Yun yung gamit ng decision tree, kaya natin siya ginagawa. I have here the illustration of a decision tree. So perform the following. Number 1, construct a decision tree. Number 2, indicate the EMB in the nodes and make a decision. EMB means expected monetary value. So in this illustration, as you can see, we have the 3 present dito, yung tatlong nodes na binanggit ko kanina. Yun yung decision point, yung chance node, and the alternatives. So, as you can see in this illustration, meron tayong amount in the right side. So, these amounts are called the payoff. Tinatawag siyang payoff because it is already given and nakalagay ito sa ating illustration kanina. And then, the 0.60 or the point and the 0.40 is what we call the probabilities. Don't worry kasi ang probabilities ay given na at hindi na natin kailangan hanapin. So, to compute the EMB in the simplest form, kailangan lang natin i-compute ito from right side to left side. So, starting in the payoff up to the decision point. However, in order to get the transparency, we have the formula. So, the formula is EMB is equals to payoff multiplied by the probabilities. So, dito sa answer to, makikita lang natin kung paano kinuha yung EMB. Sa unang solution, sabi niya dito, if Ms. Salbenbank plans to establish a branch life unit, magkano kaya yung expected monetary value niya? So, ang gagawin lang natin ay substitute ang formula. Again, ang formula ay EMB is equals to payoff multiplied by the probabilities. So, we will end up with the EMB. So, dito, so let's substitute. We have EMB is equals to 150,000 multiplied by 0.60 of favorable condition plus negative 40,000 times 0.40 of unfavorable market condition. We have 74,000. So, this 74,000 be placed in the circle 2 of chance node. And then, if ever naman nagagamit si Ms. Salbenbank ng full-blown branch, he will get 100,000. Paano niya kinuha yung 100,000? EMB, establish a full-blown branch, is equals to 300,000 multiplied by 0.60 ng favorable market condition plus negative 200,000 plus times 0.40 ng unfavorable market condition. So, meron siyang 100,000. This 100,000 naman ngayon ay mapupunta sa chance node number 1. So, the values of 1 and 2 are compared as the basis of the decision. This problem, we will get who have the highest expected monetary value. So, based on this problem, ang mas mataas ay ang full-blown branch na merong 100,000. Therefore, the decision is to establish a full-blown branch which results in a 100,000 expected monetary value. Next, marginal analysis. Marginal analysis with large number of alternatives and states of nature. Marginal analysis is a decision-making approach that is used when there are large or manageable numbers of alternatives and states of nature given in a particular problems. Marginal analysis is a fact that helps in determining the optimal and fertile level without the use of a payoff or decision table. So companies uses marginal analysis as a decision-making tool to help them maximize their profits, because instead of focusing on the whole, you can just pick an individual unit to examine or to compare it into another. So marginal refers to the focus of the cost and benefit on the next unit. So the focus of marginal analysis is to examine the additional benefits and the cost incurred in the same activity. Marginal analysis is important because it identifies the most efficient use of the resources of the companies, because it will let you know whether the action you're taking are beneficial for your companies. So, ang golden rule ng marginal analysis ay the activity will perform or will continue to perform kapag ang marginal benefit mo is equals to the marginal cost. However, if the activity performs that the marginal costs are greater than the marginal benefit, it will cause a negative impact to the company.
So let's move on to the marginal analysis with discrete distribution. So what is discrete distribution? Discrete distribution refers to the set of values in the distribution that is considered finite. In other words, the values of distribution are not continuous. Example of discrete distribution are rolling 3 dice and recording the probabilities of the sum of 3, 4, 5. So, the designation are set as follows. P stand for the probability of selling one additional unit, or the probability that the demand will be greater than or equal to the supply. MP means marginal profit or conditional profit. ML means marginal loss. 1 minus P is probability of not selling one unit. So, P times MP is expected marginal profit. So, I minus P is ML expected marginal loss. SP means selling price. QC means unit cost. And lastly, SV means salvage value. The formula to compute for the margins profit is marginal profit equals to selling price minus unit cost, whereas the formula for computing the marginal loss per unit is marginal loss is equal to unit cost minus salvage value. The basic premise in a marginal analysis that it is advisable or favorable for the business to add a unit or product to the inventory if the marginal profit is equal to or more than to expected marginal loss. It is the probability of optimal stocking. In a mathematical equation, this relationship is expressed as P is greater than or equal to marginal loss over marginal profit plus marginal loss. So, on the other hand, the optimal decision rule is mathematically expressed as P times MP is greater than or equal to 1 minus P times ML. So, the following are the steps involved in a marginal analysis with a discrete distribution. Number 1, determine the value of P. Number 2, construct a probability distribution table with additional column for cumulative probabilities. 3. Determine the level of inventory wherein the probability of selling at least one additional unit is greater than P. So, example of marginal analysis with a discrete distribution is Angel Delicacies House provides native delicacies to customers in order to flavor bibingka daily from the supplier. 1 pack contains 12 pieces of bibingka. The past records of the Angel Delicacies House provide the following estimate. 5% probability that is 5 packs will be sold. 10% probability that is 6 pack will be sold. 15 probability that is 7 packs will be sold. So 20% probability that is 8 packs will be sold, and 25% probability that is 9 packs will be sold. 15% probability that is 10 pack will be sold. So 10% probability that is 11 packs will be sold. The selling price per pack is 60 pesos with a unit cost of 40 pesos. Unsold bibingka at the end of the day are sold to piggery owner at 5 pesos per pack. So, ang required dito is determine the marginal profit per pack. Number 2 is determine the marginal loss per pack. 3. Solve the value of P. Prepare a probability distribution table with additional column for cumulative probabilities. Number 5 is solve the optimal number of pack in order to order every day. So, step 1 muna tayo. Determine the marginal profit per pack. So, para makuha natin yung marginal profit, kailangan natin pag-minusin yung selling price sa unit cost. So, MP is equal to selling price minus unit cost. So, ang selling price natin is 60 pesos, while ang unit cost natin is 40 pesos. So, 60 minus 40 is equal to 20 pesos. So, nakuha na natin yung marginal profit niya. So, doon naman tayo sa marginal loss. Para makuha naman natin yung marginal loss is unit cost minus salvage value. So, ang unit cost natin is 40 pesos. So, ang salvage value natin is yung 5 pesos per pack ng piggery owner. So, 40 minus 5 is equal to 35. So, para makuha natin yung value of P is, kailangan natin i-compute yung mga nakuha natin kanina. So, P is equal to ML over MP plus ML. So, ang nakuha natin kaninang ML is 35. And yung sa MP naman is 20. So, 35 over 20 plus 35. So, ang una nating step na gagawin is 20 plus 35 is 55. So, pag nakuha na natin yun, i-divide lang natin siya sa ML, na 35 divided by 55 is 0.64. Kung kasi nun, 0.63, niround off lang natin siya, kaya naging 0.64. Step 2 is construct a probability distribution table with additional column probabilities. So, kailangan natin gumawa ng table na meron siyang sales per day in pack, probability of sales level, cumulative probability. So, ang sales per day is yung 5, 6, 7, 8, 9, 10, 11. So, ang probability of sales level is yung 0.5, 10, 15, 20, 0.25, 15, 10%. So, para makuha natin yung cumulative probabilities is, mag-umpisa tayo sa pinakababa. So, sa 10 is 10. So, 10 plus 15 is 25 plus 25 plus 20 plus 15 plus 10 plus 0.5. So, hanggang sa makuha natin yung cumulative probabilities. So, ang kukunin natin dito is yung nasa gitna. So, ano ba ang nasa gitna ng yung pinakagitna is yung 0.70. So, ang kukunin natin is yung 0.70. So, sa step 3 naman tayo. Step 3 is determine the level of inventory wherein the probability of selling at least one additional unit is greater than P. So, since ang nakuha natin kanina sa cumulative probability is 0.70 is greater than to 0.64 na nakuha natin sa value of P as indicated by the arrow above the number of packs, where the marginal profits will still be greater than the marginal loss is 8 packs. So, Angel Delicacies house must therefore order 8 packs of flavored bibingka every day. So, illustration 6 can be solved using a payoff table or decision table, but the table will have 7 rows for the level of sales and 7 columns for the 7 percentage of probabilities. This process is very tedious compared to the marginal analysis approach.
Now let's move to the next approach of marginal analysis, which is marginal analysis with normal distribution. So when we say normal distribution is a distribution of set of values in which they are symmetrical to the mean. Symmetrical, ibig sabihin ito ay kaparehas nung amount or nung value ng mean. So, marginal analysis with normal distribution. This approach is appropriate when there are very large numbers of possible alternatives and states of nature, and the probability distribution of the states of nature is considered normally distributed. Normally distributed, ibig sabihin symmetrical or pantay-pantay. Now, there are following conditions in marginal analysis with a normal distribution. First, the MP and ML can be determined. When we say MP is the marginal profit, ML is the marginal loss. So, kailangan ma-determine yon. Second, the mean and standard deviation for the product are known. And third, the probability distribution is normal. So, mayroong mga steps involved in a marginal analysis with a normal distribution. Ang first is we have to compute for the marginal profit, marginal loss, and the value of normal distribution. And then second, we have to locate the area of P, or the value of normal distribution, and the standard normal distribution table. And third, we have to find the optimal stacking level using the relationship of values in the following formula. So the formula is Z equals to X minus mean divided by standard deviation. Now, meron tayong isang problem na kailangan isolve, which is this. Easy Refreshment Parlor wants to determine the number of plates of baked spaghetti that it should order daily from its supplier to maximize profits. A plate of baked spaghetti has 10 servings, and unsold plates of baked spaghetti are given to a home for the aged. Past sales data provide the following information. Selling price per plate is 120 pesos. Cost per plate is 48 peso. And the average plates sold per day, or our mean, is 40 plates. And standard deviation is 8 plates. Now, we have to determine the optimal stacking level of baked spaghetti. And now, for the step 1, we have to find the MP, ML, and P. For the MP, or the marginal profit, we just have to deduct the cost per plate to the selling price. So, 120 minus 48 is equal to 72. And for the marginal loss, we just have to deduct SV from the cost per plate. So 48 minus 0 is equal to 48. And then lastly, for the P, or the value of normal distribution, we just have to add the MP and ML. So 72 plus 48. That is 120. Now, we have to divide it to the ML. So 48 divided by 120 is equal to 0.4. And there we have the value of normal distribution, which is 0.40. And then after that, we have to proceed on this step 2. Locate the area of P in the standard normal distribution table. Table 1 in the appendix contains the values of the standard normal distribution. The area of P is 0.4 and the table shows the corresponding value of Z. Figure 5.1 shows the normal distribution of sales values. The area to the right of the mean has positive Z-scores. So, dito naman sa table, makikita natin na yung na-shadean is the area of, or is the area, which is 0.40. So, since sinabi nga natin kanina na ang normal distribution table is symmetrical. So, ibig sabihin, pantay yung amount or yung value ng dalawang side. While yung gitna, yun yung average nila. So, para sa right side, meron tayong value doon na 1. And for the other side, we also have 1. So, since 0.40 yung ating area, yung shade lang natin dun sa table or dun sa curve is yung 0.40. So, 1 yung buong yan. Then we just have to find 0.40. Our step 3, we have to find the optimal stocking level using the relationship of values in the following formula. So, Z is equal to X minus the mean divided by standard deviation. So, ang ating Z-score is already provided in the problem, which is 0.25, so we just have to write it. 0.25 minus X, equals X minus 40 divided by 8. Now, since ang hinahanap natin is yung X, or what we call the value of variable, or the optimal stocking level, we just have to move it or transfer it on the other side. And since fraction po yung nasa taas, ang kailangan natin gawin is ibaba yung numerator. So, since negative 40 siya, magiging positive 40 siya. While yung naiwan na 0.25 and yung 8 is ipagta-times natin. So, 0.25 times 8, 0.25 times 8 ay 0.25 times 8 is equal to 2. And yung 2 na yon is i-add natin sa 40. So, 2 plus 40 is equal to 42. And there we go. We have the optimal stocking level of 42. This indicates that Easy Refreshment Parlor should bake spaghetti every day. Let's move to the next slide. We have illustration number 8. So, in here, we will be using the same information in illustration 7, except that the cost of baked spaghetti per plate is 96 peso. Required, determine the optimal stocking level of baked spaghetti. So, in order to do that, we have to proceed on the steps na ginawa rin natin kanina. First, we have to determine the MP, ML, and P. In order to do that, we just have to deduct cost per plate to the selling price. And there we have the marginal profit of 24 peso. 120 less 96 is equal to 24. That is the marginal profit. On the other hand, in order to compute for ML or marginal loss, we just have to deduct the SV to the cost per plate. So, 96 minus 0 is equal to 96. And para naman na-compute natin yung value of normal distribution, again, we just have to add the answers or the amount or value of ML and MP. So, 24 plus 96 is equal to 120. And kailangan lang natin i-divide yung ating marginal loss na 96 divided by yung pinag-add natin na 120 is equal to 0.8. And there we have our area. So for our next step, we just have to locate the P or the area on the normal distribution table or sa ating curve. Using the standard normal distribution table, where P is equal to 0.80, the Z-score is equal to 0.84, which is given, and is a negative Z-score. Figure 5.2 illustrates the area of 0.80. So, makikita natin sa screen yung mga na-coveran or may mga lines, may grids, yan po yung ating area na 0.80. The area to the left of the mean of the normal curve distribution has negative z-scores. And now, for the next step, we have to compute for the optimal stacking level. Using the formula for the standard score, the optimal stacking level is determined as follows. Gaya lang din ang ginawa natin kanina, we just have to follow the formula na ginawa natin kanina, which is x is equal to the negative z-score, since negative z-score ang meron tayo na given, plus, or I mean times, dun sa ating standard deviation, plus ang ating mean. So, 0.84 times 8 is equal to 6.72. Since negative siya ay negative 6.72. And since negative 6.72, kailangan natin siyang i-round into 7. Now we have negative 7 plus 40. So what we're going to do is to add it. Negative 7 plus 40 is equal to 33. And there we have our optimal stacking level. So this time, the optimal stacking level is lower than the average demand because the 24 peso marginal profit is less than the 96 peso marginal loss. That's it for the report. I hope that you enjoy watching.